Okay, this video is to redo my discussion of Direct Form 1 and Direct Form 2. What I did in class, I felt like it was pretty disjoint. I spent too much time messing with the pen, and it just wasn't very good. So I'm not sure if you got the point of it, so here's a quick video to run through this in a more succinct way. All right, so we're starting off with a difference equation, and we could put it in this form. We put the y's all on one side and the x's all on the other. Okay, but then our first step would be to rewrite this in terms of just y of n. So you see here we have the x's. Okay, in class I called that w of n. He's already using w's, so let's just call this alpha. All right, and then we also have the terms with the y's on it. Okay, so by now you've seen these block diagrams with gain constants and signals indicated in the diagram and output summers and so forth. All right, so let's think of this point on the diagram alpha. All right, and so what you see here, I'll just point these out by highlighting things. You have x of n multiplied by b0 coming into the summer alpha. So that gives me this term. Then you have a delay. All right, so this delay, at the output of this delay, would be x of n minus 1. Okay, so you would have x of n minus 1 times b1 coming into this summer. That's this term. All right, then we have a delay, so this is x of n minus 2. All right, and so x of n minus 2 times this gain constant coming into this summer, that's the third term. All right, so we're on a roll here, looking now at the output of the next summer. Okay, here's the output of the summer. We could move that over. Here's y of n. Okay, so we're looking at the things coming out to y of n from this summer. All right, so I take a look. I've got alpha coming in. Well, that's been indicated here. We've already formed alpha. All right, then I've also got a delay here. So if this is y of n right here, then down here is y of n minus 1 through that delay term. Okay, so we multiply y of n minus 1 times this constant minus a1, and we add that in, and we get this term. Similarly, we go through the delay element. We get y of n minus 2. Okay, so y of n minus 2 multiplied by minus a2 comes into this summer, and we get this term. All right, so that completely describes this diagram, and what I did try to do in class was to have you notice that there's two sides to this diagram. There's the numerator side, the numerator of the transfer function. That's this side of the diagram. Okay, so everything over here is the numerator. Okay, so we're going to break it at this line here in a second and transpose these. All right, then I have another side to this. That would be the denominator side, where we have the y's. Okay, we pick up that summer as well. Okay. All right, so this block is essentially 1 over d of z, where d of z is the denominator. Okay, now here's the thing, we talked about it in class. These are linear systems, and so if I had two stacked or cascaded transfer functions, n of z and 1 over d of z, the order does not matter. Okay, so I can split these. All right, so that's what happens on this next step. Okay, so you see we take this 1/2 that was red, and we move that over here. I'm sorry, we haven't moved it yet. I just recopied that. So recopying this, here's this one side. I take it and I move it over to here. Here's the other side. I take it, including the summer, and move it over here. Okay, so what does not move is the input. We still have x of n coming. We still extend this out. This signal is y of n coming out. Okay, so y of n and x of n, it's the same at the boundary. We just flip the order to get to direct form 2. All right, so what we notice at this point is that we have these two parallel paths, and if this is the signal w of n right here, it doesn't change if I move over. There's still w of n. So we notice that this path with these two delay lines, they're actually identical. So you can consolidate that into a single path, which is what's done with this step. Okay, so we consolidated that to a single path, and then the B's get picked off, and the A's get picked off, and we end up with direct form 2. Direct form 2 is not immediately obvious, and that's the only purpose of direct form 1, is to get to direct form 2. All right. All right, so once we have direct form 2, we have this diagram, and we can implement this diagram with pseudocode, and we end up programming a filter. Hopefully that's helpful.